putting together putting together a presentation would be really nice. It's not required, but it's nice. But when you make your forum post, rather than just posting your code there, add some additional information about maybe why you chose the model, the challenges you faced, the limitations, anything that you can describe to help the judging team, the judges, to understand how your model works so that they can try it out and get it to work too. But then your thinking behind it, any limitations, future work that you would want to do, like, really kind of try to start and build out a conversation so that the so that not just the judges, but everyone participating in the hackathon and people come to the forum have gain a greater understanding of your thought process, and just and how your solution works in general. And that's going to go a long ways towards demonstrating the value to the team, and you know just essentially helping you along and helping everyone else along too.
Yeah, and while it's not required to do a demo in today's session, it's definitely super helpful. It gives you a chance to, if the judges have any questions about your project, if they're wondering why you chose to do that project specifically, it gives them a chance to actually have kind of a dialogue with you. Whereas if you just submit it and you don't do a demo, folks have to kind of just make assumptions based on what you've submitted. So.
Yeah, think of it as a sales pitch. Like, sell us on why your thing's cool. Like we love hearing that. That worked real well our last hackathon. The we had some really impressive presentations that really sold. Like, without looking at it, we couldn't tell that this was, you know, the first time that somebody had ever built a Gaussian splatting algorithm on AMD GPUs. And it was like hearing that from them and saying, "Oh, that's pretty cool."
Yeah, definitely. Mohammed?
Yeah, this question is for Chris. So I don't know yet if I'm going to be able to do a demo, but if I do, will I still have access to the B200 while the judging period is going on?
Yeah, we have the B200 available to us until Monday morning.
Okay.
So, we wanted to make sure that we had enough time so that nobody would lose access to their machines and things would be shut down. So what I would recommend though is this machine is a little bit unique in that they've been allocated to us kind of as bare metal machines out of a pool. So I would just encourage you to back up your work frequently, because if the machine goes down for some reason, like let's say we run into a kernel panic and the machine goes down, we'll want to be able to restore your work. I have a backup machine in case we need it. Um, but just make sure you're backing up your work and getting yourself into a state where if something happens over the next 8 hours, we don't you don't wind up losing your entire work stream.
Okay, cool. Thanks.
Yeah.
And also, it's totally fine to record a demo. So like you don't have to do it live.
Yeah.
Like,
Mhm.
record a video of this working just as a backup in case you run into flaky network connections or it goes down or something like that on you.
Yeah, yeah.
I think a few other folks have joined. Any specific questions that we can help with? Is my slide still shared? The office hours slide?
Yep.
Okay, thanks.
Mm.
I have a very simple question.
Yeah.
I was interested to try Micron on the AMD GPU, but I don't see on Lambda, I don't see AMD GPU available. So can we try somewhere or no?
Yeah, Lambda does not have AMD available. Brad, I don't know if you have ideas where what would be the best place for folks to try that.
Well, let's see. So like very basic like GPU function code, the kind of things that are like in the puzzles, those should run on AMD RDNA GPUs, like RDNA 3 and higher. So if you have access to like even something like an integrated like 780M that's in like a laptop, integrated GPU, you can run like the basic GPU functions. We haven't yet built out the full WMMA instruction set for those. I have like a patch for some more of those to fully enable like the tensor core math that we need for like flash attention. So things like the full model architectures, you can run graphs, but you can't run full model architectures yet on those RDNA class GPUs. So if you have one of those available, you can try it out. I also don't know, like, we also have, like, if you're very interested in trying things out and working through things, I believe that we still have our partnership with TensorWave, where you may be able to, not, it won't be done in time for the hackathon, but if you really wanted to work on this afterwards, I believe you can contact us, and I believe TensorWave is offering MI300 access still as
Mhm.
part of like a trial period. So I think they can get you a little bit of
Yeah,
credit on there.
yeah, Brett, I actually need to interrupt you there.
Oh,
The TensorWave has actually stopped. We've
oh,
that
okay. I
partnership is
apologize.
shut down.
Sorry.
Yeah, that was kind of a
Yep.
limited time after the release. So I don't want to set anyone up for disappointment if especially over the weekend. We wouldn't be able to get any
Oh, yeah.
TensorWave
Yeah.
allocation for the weekend. So
Sorry. Yeah. So I think best solution would be if you can try in like a local AMD, but unfortunately like our full support on like RDNA GPUs like you find consumer grade isn't totally there yet for running full models.
Thank you. I have a NVIDIA GPU, so I cannot try it locally. But yeah, I was interested to know if it can work. Thank you.
Any other questions?
I do have a question if you can hear me. I can go ahead.
We can
Yeah.
hear
So mine is a bit of a technical one. I think I would need to share my screen for this.
Sounds good. Let me stop sharing.
Yeah, it should be this. So I'm trying to write some tests and I'm trying to build a graph. So for this function that I have here, I don't see any errors here, and these are clearly like tensor values. But when I run the test, I get this error right here, which is saying that these things right here that I use in the range are not numeric. So on this line.
Oh, yeah, if you look at the ops.range signature, there's probably an outdim argument. Is there?
Yeah, should I necessarily fill that in every time I call the function?
Yeah, so this is saying like the output shape, like the result type is data dependent. So you have to kind of tell it what the result type is going to be, and you do that by specifying the outdim.
Oh, okay, right. Perfect. Then it's not too serious. All right, thank you.
Yeah, no problem. Let me know if it works. Or let us know if it works.
Yeah, sure. How can I contact you on Discord?
Oh, sorry, Caroline, go ahead.
Oh, I was just gonna say, yeah, if you just post in the Modular Hack Weekend channel in Discord, I can make sure that Brendan sees it.
Perfect. Thank you.
Thank you. It looked like I think I saw Thomas raised their hand. Yes.
Yeah. So I do in fact have one technical issue. I can share my screen maybe. Uh, yeah. So I have this code here for my benchmarks, and it's at compile time, and it's an argument. This argument, especially, it's a number of qubits here, and when it's a very high number, it creates this error. Could not simplify at during compilation. So it's when I build, it creates this error. So I think that's just a limitation of the compilator, and I cannot do anything because when I try with a smaller number, so this number here decreases, and it works when it's below 30 or something like this. So do you know if I can do something? Or?
This looks like I don't know, like Brad, do you have any ideas? But this looks like the elaborator is failing due to like some.
I can probably run the command myself because here we don't have the full output. I'm sorry.
But yeah, I think you're running into some limitation like related to
Is it
going
too large?
beyond.
Is it too large of an integer literal? Like, is that?
Yeah, exactly.
Yeah.
Yeah. Something like the elaborator won't fold things if it's going to produce different results on different architectures. So I think it's like something in that area of bugs and issues. So
Yeah,
I mean, to
it
answer,
works fine for smaller number, and that's fine in my case. Because
would
else,
you mind? Sorry, go ahead.
yeah.
Yeah, I think I mean it says where like the I think it gives where the call site is that you're actually hitting this as it's being pulled in. I mean, aside from like seeing the this, I'm guessing it's an integer literal. It's just like outside of the range of what we can support for this. It's just too big.
Yeah, because it's power of twos, so it grows very quickly.
I mean, just for like the data type itself, like
So okay, I can change the data type, and it should help. So do you want to see the code or?
uh, sure, if you have the call site where like you're passing in the specific like integer literal to the
So it's
If you cast to int 64, do you get better behavior? Like if you use int
I don't
64 explicitly instead of int here.
okay. So it's in here of qubit int. So this value.
Yeah. Did it give you a line number, by the way? Did you know? Do you know which line is?
yeah, because it looked like it was a specific comparison operator was failing, like a less than.
Oh, it's like
Sorry.
nice. Okay, like line 40, I believe.
This is
Oh, no,
line
that's the function. That's
40.
the function definition. 318.
And then
oh no.
data vector. I do this. But I don't know where this 1024 comes from. do have some, but it's
Oh, okay.
example benchmark. It's commented here, and it's not in the same. I have no idea.
I would suggest trying to use int64 instead of int,
Here,
if
for
that's easy
example,
to try. It's like, yeah,
I don't know if that will compile now.
probably not, but you probably have to do
Probably
some work
not.
to like push it through everywhere.
Yeah. Int. Yeah.
Or if we knew where it's causing issues,
Mm-hmm.
you could cast.
I don't know. It's my first time using Mojo, so excuse me. Uh, yeah, no, I don't think I will be able to do it on my own here. Uh,
Yeah, it might be difficult to do on the fly.
yeah. So yeah, do you want me to report this?
Might be worth. It's probably worth reporting if it's not, if it's convenient for you. But I feel like it's going to be a known issue
Okay.
where basically like I think like my high level understanding of what's happening is the compiler does some constant folding, like evaluating constant expressions, and
Yeah.
during that evaluation, it would have produced some intermediate that doesn't fit in a 32-bit int. And instead of just like truncating and producing the wrong result on some architectures, the compiler's like, I can't do this. Yeah, and so it just fails.
Yeah, instead of doing like a downcast that might quietly produce bad results, we error out.
Right, right, right.
Yeah,
So this is
I
yeah,
see.
because this is happening before you're using int, which is an index like MLIR index, which will have a different bit width on different architectures, and this compile time evaluation is happening before any like architecture specific code
Okay.
is generated. Yeah,
Okay. I will try to work a bit with the int64, try to see if I can
yeah.
solve
Try to
it.
use int64. Hopefully, it's not. Hopefully, that's not too painful.
Yeah, that should be
Should all.
okay. Thank you.
Yeah, no problem.
Any other questions? Hello, it looks like we have another person who just joined. Let us know if you have any questions. Oh, they're just connecting to audio now. Hello, if you just joined, let us know if you have any questions. I am going to put on Zoom music in the meantime.
I do have a question.
Yes.
So, for the judging, what sort of benchmarks should we like have? Like, what is the goal of like? I mean, like, what is the Should we what should we provide? Like, what type of benchmarks or like compare? Should we provide like comparisons or what would be like a industry standard?
Yeah. So I think that if you're thinking about a submission and how you want to compare to other models, I think the first thing that you want to do is just validate correctness of the model. And so like the per any other benchmarks or any other comparisons don't mean anything if you don't have some comparison that is I can take a model in and I can compare it to a PyTorch model or some other implementation of the model. And then from there, it's nice to have the benchmarks. And I think that Brendan and Brad may have like a little more like insight into how to like effectively do benchmarks. It can be hard to do it from like the command line because warm-up times for models can be a little bit difficult. Like if you do it from the command line, you know, from like from the terminal, you wait like the first time you may pick up the compile time, but then after the model's compiled and that compilation has been cached, you're going to wind up, you know, being able to run it faster. So really I would put timing blocks around kind of like the inference steps and try to do a large number of inference steps so that you even out any warm-up time, any, you know, any cache warm-up time to help make sure that you're directly comparing, and then just make sure you're measuring the same thing, right? And so if you're measuring inference time on a max model and then you're using a PyTorch model, like make sure you're running the same models with the same parameters, and using the same entry points around where the inference is happening. So those are kind of like rough guidelines, but you know, and wrapping these up in scripts that are reproducible is also important so that people can reproduce your work, they can validate the correctness of it, and yeah, that's kind of the advice that I have for writing up benchmarks and writing up how you're thinking about performance and comparison.
Yeah, if you have a project, the first thing is just make sure it works.
Yeah.
And so if you have like a standalone project, you know, check out the project with like the Pixie TOML and the Pixie lock, because that'll like if you're working in Pixie, that'll give us like the reproducible environment to what you have there. Makes it very easy for us to work with. If you're working with a traditional AI model, like we don't have our max serving infrastructure has support for text to text, text plus image to text kind of models directly in serving right now. Those are very easy to incorporate. But if you have something that's outside of that, like just put together like a Python script that can take input. So like if we're talking image classification, like take an image or images and then produce like the classification results from that and print that out. That's perfectly fine. Just showing that it's loading from end to end. You may need to also have like a script for like loading weights. To make sure the weights are loaded appropriately that we can set things up in there. But just like a reproducible example that shows it working from end to end. But if it's an LLM style model that will fit in with the serving architecture, you know, make sure it runs and then make sure it serves within the full like you can do a either through the endpoints or whatever you can do a max generate you know this and give it a prompt. It generates reasonably looking text. Um, and then I think that we do have, if you are able to get it up and going with the serving architecture, I think we have benchmark scripts. I'm looking for the location of them, where if you start up the server, you can run this script against the endpoint, and it'll give you metrics on like tokens per second and so forth on a given GPU. And so if you wanted to have that to compare against, you know, like another specific model that you were serving via VLLM or something like that, that's a little far along though. Like, I mean, I think like basically we're happy if you can get the model up and running and showing reasonable output. That's a great success for a hackathon like this.
Is that also true for the kernel track if we still have to provide like some model that it's benchmarking against? Like,
Oh no, like again, like there in the case of the kernel, like it would be simply like showing the kernel running in isolation, either directly via Mojo or like as incorporated into like a custom operation in a max graph. Just showing like, and then like showing comparative like tests of it with inputs to outputs to make sure it is generating the correct output. And there we have like our benchmarking module. That we have a few
Mhm.
examples, I think, in our open source repository about how to hook up benchmarks to that, and those will generate like realistic benchmarks for
Yeah.
CPU and GPU, where you can
But
get like output on that to see the performance. And if you have like a before after, like we have an existing kernel, you can have the benchmarks run against one of our existing kernel implementations and then against your kernel implementation, and it should be able to show the before after
yeah.
on the performance there if you're focusing on performance for a kernel.
But the other thing that I added there too is like even on like the kernels, like it's almost more important to verify correctness on the kernels because it's very easy to write a benchmark and say that like, wow, I'm 10 times faster than the existing thing out there. So having those tests to make sure that the thing you're benchmarking against or the thing that you're using as your standard that are producing the same results on the same input is really important. And if you haven't done this sort of benchmark before, especially for anything that is floating point math, don't use the equals function. Almost every platform provides some sort of like is near function, which gives you an error tolerance for the comparisons because different implementations will result in different rounding errors as you do the computation. And so you'll want to make sure that like when you do those comparisons, you'll save yourself a lot of heartache if you realize that you're comparing floating point values with is near and you want the values to be close enough rather than exact values.
okay, thank you.
Thank you. Any other questions? It looks like Benjamin has a question.
Testing. 1, 2, 3.
There's a lot of
Turn off my air conditioning. Okay, I guess that should be better.
Yeah.
So I'm sorry for not having much progress. I literally vibe coded my laptop to death, like as in it doesn't boot anymore because I was running 6 VS codes at the same time. And I didn't really ask this question. I probably should have asked it before, but I have a model server that I built from scratch that I was using to target every single consumer device endpoint, both in Python and in web GPU / WebNN, because I was trying to get away from Python because the rest of my tooling is all in TypeScript and web-based. And I didn't really understand correctly or couldn't disambiguate the contest rules as to whether or not I could just create another hardware target, uh, such as the Mojo Max, and then try to modify the generators that I generate all the tests and the individual skill files that do the inference. And I didn't know if this was in compliance with the rule or whether I should do something from scratch so as to give everyone else like a fair chance.
Well, yeah, I don't think you're going to be able. So, bringing up a new hardware target, especially something like web GPU, I don't think is practical or even possible with like what we have exposed as far as the interfaces right now. Like we have in open source, we have the ability to extend to the architectures that we have support for. So, like the general AMD and NVIDIA architectures,
No,
we have
I
enough that.
think you misunderstand, I guess, because I did a bunch of work. I like kind of put it in a good spot like 2 or 3 months ago where I have like OpenVINO, MPS, ROCm, CUDA, and then I was like, I'm gonna migrate from Python eventually. So I added 2 targets as like sort of universal targets because I'm sort of tired of maintaining all these bespoke hardware platforms, TBH. So I was like thinking to myself that web GPU and web NN might be the future. So I added 2 more targets. And the question was more about the contest rules. So can I add one new target, like the Mojo slash Max, and have that be my universal Python, hardware agnostic sort of layer, and then I'll keep, web GPU as my TypeScript layer? Or should I be more considerate of the other contestees by starting a project from scratch and not like taking something that I already put a bunch of work into and saying, hey, look, I'm here, boss, I did it for you.
Yeah, I can clarify. So we are asking that projects that are submitted for the hackathon were built during the hackathon period. So starting on Friday, ending today.
Okay, thanks. That was the question I was looking for.
Thank you.
But using like Mojo, if I understand right, you'd use Mojo as like a target for, you have your device independent layer. You would do like basically a code gen down to Mojo for what you're starting from, and have that like delivered to device.
Yeah. Because what I do now is I do like this code gen, but for each individual Python hardware target, like if it's Apple or AMD or Intel, et cetera. And it's a giant pain in the neck, quite frankly. And so previously I was thinking of, hey, maybe just the browser is like the universal target and just target the browser. And I didn't even consider Mojo or anything. But I already had like, I don't know, 150 different Hugging Face model classes working in WebNN, Web GPU already. And I didn't get to the full 300 plus classes yet, but I did already have 300 plus classes with all the other like Apple, et cetera, on Python. And I guess she told me the fairness of the challenge. So I'm not going to drop like some project on everyone that I worked on for a couple months and then just picked up again.
Makes sense. Obviously, we'd love to see the project. You know, we'd love for you to share it in our forum.
Yeah, so were you writing the Mojo interface before the hackathon started?
No, I did not. I didn't even touch Mojo until my friend Todd, who worked at Risk, told me about Mojo, and I should
Yeah.
take a look at it.
Yeah. I mean, I think that like where the line is, like there's going to be a bunch of things like you won't be able to build. Nobody's going to be able to build anything out of whole cloth. Like we're all working from existing libraries. And so if what you're demonstrating, if the work from the hackathon is the demonstration of extending an existing project that you were working on before, like I don't think that would be outside of the bounds of what we were expecting. Like if you had coded up a Mojo interface to like a TypeScript front end that was uh, you know, lowering code into Mojo and it was beforehand, I think that would be like that was the project. That would be unfair. But if you're extending an existing system, like that seems entirely reasonable to me. Um, and I see one of the judges is here, so I don't know if if he has an opinion.
But let's just be real, like the challenge
Yeah.
of trying to target consumer devices on Python is a mess.
Yeah.
I don't have a strong opinion on that part, Chris. I just something something to think through for sure. Yeah, the consumer stuff is. I mean, the device fractioning, well, that's not the word I'm looking for. Sort of the fracturedness of the entire space, I think makes like consumer stuff way more complicated in general. I mean, like it's kind of the edge experience that we had even when we were back in startup mode.
Yeah, and then I'm also incorporating like this sort of local first, like you keep all your data private sort of concern. Like I'm trying to allow this to be used for like doctor offices or children or lawyers without worrying about, your information being exfiltrated from OpenAI because of some New York Times lawsuit.
The judging panel. The judging panel is Chris Latner, Jared, who's here from NVIDIA and Octo AI, Corey Lohman, who is from Lambda, and then we have Owen Hilliard, who you might know if you've been in our Discord or our forum at all. He's super, super involved. So. Giannis, I think this is the right place for specific questions, and if the folks on this call can't answer them, we can point you in the
All
direction.
right. Yeah. So, I just really quick. Is there an echo in the background? Can you hear me?
We can hear you. Yeah. No.
Okay. No echo. All right. So maybe I should share my screen, or I'll do that later. But using this Max Graph API, when you're defining a new operator, you have these input buffers and output buffers. Well, let me just make sure I have the name right. Yeah, input tensor and output tensor. And those typically get casted straight to a layout tensor. But when you're trying to use the standard lib, utility functions like mean or other reduction kernels that I'm trying to use, they require a raw buffer. And I've been trying for like an hour and a half or like 2 hours now, trying to get a buffer to the actual underlying data. And I haven't been quite able to do that. So I was just wondering if you had any idea.
So like we're lacking a few abstractions at that level. I mean, we were just discussing this the other day. So for layout, like layout tensor, we have some. You can look and see this inside of the kernels. We have some ways of in some of the kernels are still relying like an older data structure that we're moving off of called ND buffer. And so there's some mapping to ND buffer, and then some like operations like operate on ND buffers from there. We're trying to migrate from like off ND buffer to layout tensor, so we're gradually driving layout tensor throughout the stack there. But things like some things in the Mojo standard library, you have some approximations that they were built for use on like CPU based types as opposed to operating on like GPU layout tensors. And so you may need to look inside of like thankfully we have all of our kernel library available, so you can look in the max kernels and things like the kernels NN, kernel linalg, to see how we may have approached the same problem for mapping or parallelizing across them. We have some higher level abstractions, such as like for element-wise operations, you can apply at the max graph op level for each operator. That'll apply a lambda across like each element, and it'll automatically like load balance, parallelize as appropriate for whatever accelerate like CPU or GPU that you're working off of. Um, we haven't yet driven up some of those the higher level abstractions for more functional programming, like I say, for like a true map or others, to be operating generically off of like the input and output tensor are actually like aliases to manage tensor slice. And so working directly off of those or working directly off of, say, a layout tensor. But if you have a specific pattern in mind, you can maybe find one of our kernels that has implemented something close to that. And we probably have like whatever the specific application is of a given function right there. Yeah, I apologize for that. We're trying to get like we had built a lot of these kernels like ourselves to drive to performance, and now we're paying down some of the tech debt on like getting the abstractions upright to make it even easier to program against them.
Yeah, that makes sense. Yeah, that ND array stuff. I've been trying to use a layout tensor to use the mean kernel that takes specifically an ND array. So those max kernels that I was looking at, maybe I misunderstood. I was under the impression that on the docs where it says max kernels, these are operations that you could only like specify on a graph within Python. So if you're using the Graph API, you can only use kernels there, and you can't use them within Mojo itself if you to interop with some of your own kernels, or if your entire program is running throughout a Mojo program rather than a Python program. Maybe I'm wrong there. If you could clear that up.
Yeah, so you can use them directly in Mojo. And so it's kind of hard when we define kernel, like it's hard because like there are functions and subfunctions and subfunctions. They're all defined within, so we've open sourced all the libraries for those. And you can use them locally. Let's see, I'll have to see, like, I think I can probably check on this, but I think we have exposed, I know there's at least one forum post about this. I think we've exposed the libraries themselves. So you can directly import the libraries and call into the functions themselves. And then if you modify any of those kernel functions, we have a Bazel build process where you can build a custom kernel library that has your modifications incorporated in it and call on that from a local Mojo project. But all of the functions that make up the kernels should be available, should be public. They should be directly callable. And so, like for example, matrix multiplication at a very high level, we have the mo.matmul operation, which then is our matmul kernel in the graph API. But that is actually like there's a tree of different functions that specialize down from that, depending on which architecture you're working on. And you can call any of those at any level directly from Mojo code. And if you want to see how they work or how they're used, we have open sourced all of the unit tests for all of our kernels and all of the functions, and those unit tests are in Mojo. They call directly into the Mojo functions themselves. The very top level definition, it's hard to find, is and we don't like totally explain where this is, but the top level definition for all of the kernels that we use in the Graph API is in a file called mogkernelapi.mojo. It is a gigantic file that has the registrations for each one of the. Yeah, thanks, Brendan. Yeah, it is a huge file. We open sourced it, but we didn't like call out that this is this thing. We need to change some of our naming on this. But this is the main registration for every graph kernel that is used in a graph. And from there, you can look and see what is called in Mojo, and you can call each one of those functions directly in a Mojo project yourself.
Okay, I see. Yeah, that helps a lot. Thanks for the response.
Any other questions?
Is it cool if I try to ask like a somewhat long question potentially?
Yeah, go for it.
So basically, okay, I don't have that much experience, so I might be very confused, but basically, I was trying to implement like stable diffusion with like max graphs, which might have been like a bit harder than I anticipated. But basically, I was trying to, so my understanding is that there's like this UNet that's like pretty core to stable diffusion because we need to like do this in like this diffusion or like this denoising loop. But I kind of wanted to like test like all of this without actually having to like implement the like UNet completely myself. So I thought like maybe there would be like a way to like port it temporarily to like test the rest of the code. Um, and so yeah, I was kind of struggling with that because I wasn't sure exactly if there was like a way to do that.
You mean you want to just have the UNet architecture itself in something like Python, PyTorch, and then build out the rest of it? Is that what you're looking for?
Yeah, exactly.
So you should be able to do that. And one way to do this would be to if you because it's like because the stable diffusion is like several subcomponents, and I think the UNet one is kind of isolated from the others. What you can do is you can build out a max graph, and you get the max driver tensor out of that. The max driver tensor can directly map to a PyTorch tensor using the from and to DLpack methods. And so by using those, you should be able to go, I think we have an example of this in code. If not, I can find one. Um, where you can go from a max driver tensor to a PyTorch tensor, run the PyTorch portion of the UNet graph, then go from the PyTorch tensor back to a max driver tensor, and then run the rest of it through a max graph. So you should be able to inject a PyTorch version of the UNet in between max graphs if you want to test that way. Otherwise, I think there are ways of like testing. You can test those subgraphs in isolation, in comparison versus like if you have a PyTorch version of the subgraph and then a MaxGraph version of the subgraph, you can try with the same inputs and verify that they produce the same outputs from those two different graphs. You want to do that. This is what our team does when they are bringing up a model from scratch, is build like smaller subgraphs and compare them versus their PyTorch equivalent. And just like verify that the inputs and outputs are the same. Even for like random inputs, provide the same random inputs and make sure they produce the same random outputs within like a certain threshold.
I see. Okay, interesting. Okay, thanks. I like wrote down some of those things you mentioned. I'll try to look into them and then get back
Yeah, if
to
you
you.
want, if you still are looking for that and want an example of it, ping in Discord or in the forums. I can see if we have some good code examples of that.
Okay, thanks.
I linked a couple for to and from DL pack. I don't know if they're the best examples.
Cool, cool. Appreciate it.
Any other questions?
Oh wait, actually, I might have another question as well. So when I was like building this out, I was thinking, is it probably not good to, or initially I was using I forget exactly what it's called. I think it was so there's like these pipeline like classes, I guess, that like I guess a lot of the models like that are already like implemented like kind of just like use. But I was thinking that if I wanted to use like if I want to do diffusion, maybe I don't want to actually like wrap it around like one of the like existing pipeline classes necessarily, but I'm not completely sure because I thought those were like focused towards like more like text-based like models. Although I guess like Stable Diffusion is kind of like a text-based model, but like I wasn't completely sure because yeah, I'm not sure.
So by pipeline classes, you mean like pipeline? There's like pipeline model and like text generation
Yeah,
pipeline. Yeah,
yeah,
you
exactly.
probably you could probably subclass. No, they're both pretty text generation focused. So you might need to roll your own thing there.
Okay,
Completely from scratch. Sorry. Yeah, they have like next token. I think even pipeline model has like a next token interface. Unless you
okay,
like
yeah, yeah.
really like try to shoehorn image generation into that, you could try.
Okay, yeah, that makes sense. That's good.
Yeah, text to image modalities are on our to-do list, but we haven't quite gotten there.
Yeah, it's coming.
I mean, okay, I don't want to flex or anything, but I am like the MLOps lead at Lion, which is like a nonprofit that did the Lion 5B and the image diffusion stuff before Ahmad got in there with all the money. And there's a thing called a clip encoder, which is sort of like when you take the embedding layer from the last token in like a BERT model, for example. And so you should be able to sort of, with the clip embedding, then be able to feed that into the UNet and have the UNet be mocked in PyTorch and then exchange tensors between the clip and the UNet, and then just try to make sure that your UNet is to the same standard, and then you need to finally get out of the latent model, you have to have a decoder from the UNet into the pixel space once you have each round of noise denoising go on. And it's totally possible, but I'm not, again, like really not an expert on Mojo, so I don't really feel comfortable endorsing this idea. So, just for what it's worth.
Yeah, it's a sensible work plan. I know like Zhang was hacking on some of this before. Like, and again, you could like just say, yeah, split the sections out and work on each individually. Like, yeah, like the clip and others.
I don't remember if this was asked directly on the call or not, but so for the B200, those are gonna wind down on Monday or so. But if you have existing Lambda credits, those are good for 12 months after the event ends. So if you don't use all of your credits, you should feel free to continue using them. But one thing that we also want to make clear too is that any usage of Lambda Cloud beyond that will be billed to you. And so you'll want to monitor your usage to make sure you don't go over. I think that if there's a small mistake, Lambda will work with you to make it okay. But you want to make sure you don't have like a long running GPU project and then wind up with an unexpected cloud bill.
Yeah, we'll make an announcement about this in the Discord as well, and we'll send out a reminder email when the hackathon wraps up.
I guess I should probably ask this just for the sake of when I communicate to others. Oh, by the way, like I hang out in the Yannick Kilcher machine learning Discord, and there's like 1 to 200 people that show up every weekend for the preprint archive paper discussions. So I'll try to tell them what I find out here next weekend. But what is your compatibility like with regards to more like the data center accelerators? And there have been some people who've been really interested in at least some of the Intel cards because they have some tremendous amounts of cache, which is good for like the test time compute and other things like having big MOEs. And I don't know how good Mojo is with like sort of intelligently with deciding how to allocate stuff, or whether all the kernels that you guys want to be making with this should be done like with the handcrafted kernels rather than like the graph compiling method, or whether or not the graph compiling method is like hardware intelligent enough to sort of figure out how to put things or how to minimize memory movement from different cache levels.
So at a high level, like in terms of like hardware compatibility, so we have like tiered hardware compatibility that we list. So for the data center GPUs, um, it is, let's see, Ampere, Ada Lovelace, Hopper, and we're bringing up Blackwell. So Blackwell is mostly functional for what we're doing, and so it's across all of those architectures. And then on AMD, like MI300, MI325 are what we certify and test in CI. And we got an eye towards the 350s as we can get access to them. But like 300, 325 is what we work with right now on the AMD side. And then like consumer grade GPUs, we match the same architectures on NVIDIA GPUs. We have like lower level support for Turing GPUs in that like you can do like basic GPU programming, but we don't yet fully have all the tensor core operations built out for that specific GPU. So like the matmul based models aren't the best on Turing GPUs. And then like AMD, like we have basic support for RDNA 3, 3.5, and 4 GPUs. We don't yet have, again, don't have the tensor core equivalent, the WMMA operations fully like run through for all of those. So like full models and model graphs aren't yet fully functional on the consumer grade GPUs there. And just to clarify, like Mojo is our language that we use for doing kernel authoring, and low level like performance programming. The actual models themselves are being driven via the MaxGraph architecture. So we have the MaxGraph compiler, where you define the computational graph for the models. Each one of the nodes in that graph are written in Mojo. But the graph compiler is independent of Mojo, and so right now our most the API that we put the most effort into is a Python-based API that allows you to define the models, integrate like I said, integrate easily with PyTorch, existing ML workflows, and so forth. Define the computational graph, and then use the graph compiler to do that. So it's a hybrid mix of a graph compiler that can do optimization and fusing for you with handwritten, hand-tuned kernels. that we can, in the places that it makes the most sense, we can drive those with our architecture specific optimizations for given hardware architectures.
Okay, we have like, I guess, almost unlimited Intel hardware. And it's partially because I used to work there like 10 years ago before I acrimoniously ditched the place. But I live right next door to the factory, and they're giving the Lion nonprofit just a bunch of compute to do open source stuff. But the software is subpar with regards to like the actual inference code and making sure that their Habana graph compilers are working well. And I'm not trying to put more on your plate. Sounds like you guys have a lot on your plate, but maybe if you think it's a good idea, I'll tell the Intel people they should just like have their people move. I mean, I know what so-called one API was like, their dream to have everyone use the same common standard, and the XKCD comic where we need a new language and there's another language. But I am always very disappointed by like getting blue screens of death on the consumer hardware and on the GPU hardware, like not being able to quantize to 4 bits or having to like essentially wait several months for features that have been already implemented in NVIDIA or AMD. And sometimes it's very frustrating, and I almost feel like they should do something different. I don't know. I don't want to put them on blast, but there's people there who I think are missing the ball.
Well, we love up leveling the software that's out there for developing models. And yeah, I mean we obviously can't comment on like hardware that we're bringing up, yeah, until we don't like talking about it until we actually have it ready. Just so we don't promise more than we can. But we love being able to expand into new hardware platforms. But like the AMD and NVIDIA GPU, like data center GPUs are primarily what we support today. But we are looking at expanding.
Yeah, and ultimately we do want to be able to have community support for a broader range of hardware too. Like this is, so you should expect to see more of the interfaces for lowering down into specific hardware types become available as time goes on. I mean, that's an important thing for us because, one of the goals of Mojo is to be able to use it to program any hardware that you want. And so to do that, making in, experts of particular hardware types, giving them the ability to bring up that hardware is pretty important to be able to kind of like realize that vision.
Yeah, so where are you guys at with regards to like open source and like do you guys, since I always get a constant stream of college students,
hmm
do you guys do Google Summer of Code or anything similar to this?
We haven't done a Google Summer of Code quite yet, just because um, it's hard to scope out a project. Well, first of all, like the open sourcing of our code base has been progressive over time. So it was about a year ago when we open sourced the standard library. We just opened up the kernels and the graph libraries this year. And so I think that we are still a ways away from the sort of open source infrastructure you need to really effectively support a Google Summer of Code project. So definitely not this year, but like there's no saying where we're going to be next year, and we should have like we've talked publicly about open sourcing the compiler and runtime by the end of 2026. So, that those are some rough timelines as to like what our open source strategy is for that.
Well, apparently my friend and former college buddy over at Red Hat seems to think you're on the right path, and I saw LLVM and thinking that maybe you're on the right path too. But I'll try to find out this weekend and
Mhm.
see how it goes and get back to you with my feedback.
Thank you. Mhm.
Sounds good. Thanks so much, everybody. Are there any last questions before we wrap up? All right. Well, I'm going to announce this in the Discord in just a moment, but we're also going to be hosting a live show and tell session with Chris Latner today at 1:30 Pacific time. So I will put the link in the Discord. Feel free to swing by, share your project, get feedback from Chris. And again, all projects are due at 4 p.m. Pacific today. Thank you.